Hello viewers, you're welcome to another interesting lesson on Obasimatic tutorial. Today we are going to learn how to solve simultaneous equation that will lead us to a quadratic. We start wasting much of our time, let us go to the board. The question we have today is x plus y is equal to 5, xy is equal to 6. In other words, we are looking for some values of x and y such that when we sum them together, we will get a 5, and when we multiply them together, we will get a 6. Now, if you see the equation 1, the variables are distinctively separated, but in this other equation, the values are not separated like that. So it will be very easy for us to solve this problem by the use of substitution method. So what we are going to use, the method we are going to use in solving this problem is the substitution method. So the first thing I will want to do is to name this equation. So I will name this one equation 1 and I will name this one equation 2. Okay, now from equation 1 I will make either of this variable the subject of the formula. So I would like to make x the subject of the formula from equation 1. So from equation 1, make x the subject. So I have x plus y is equal to 5 as my equation 1. And if I want to make x the subject, I have to take away y from this left hand side to the other side of the equation. So I'll have x is equal to 5 minus y. Because when a positive y moves to the other side of the equation, it's going to become a negative y. So I will name this equation equation 3. Remember, I got this equation from equation 1. So that means equation 2 has been idle all this while. So what I'm going to do with this equation 3, I'm going to plug in this equation 3 into equation 2. And let's see how the result will be like. So put equation 3 into equation 2. And equation 2 is simply xy is equal to 6. If I want to put in equation 3 into equation 2, it simply means that wherever I see x in equation 2, I will substitute it as 5 minus y. So this place I see x becomes 5 minus y. Then I have my y outside equal to 6. Then the next thing we do is to distribute this with y. So I have y multiply 5 and y multiply negative y. So y times 5 will give me 5y, and y times negative y will give me negative y squared equal to 6. If I arrange this thing in an ascending order, or if I rank this algebraic equation, I have something like this. I have minus y squared plus 5y minus 6 equal to 0. That is, I want to arrange them in a standard form where the powers of y are in descending order. Okay, now you can see the power of y is 2, here is 1, and for here it is 0. I don't like the minus sign to start the equation, so I'm going to multiply both sides by minus 1 to get rid of this minus sign in front of the y squared. So I have y squared minus 5y plus 6 is equal to 0. What I've just done, I multiplied both sides by minus 1, so it eliminated the minus sign from here. So I'm having a positive y, and here I'm having a negative y, and here I'm having a positive y equal to 0. Now we have a quadratic equation. So we are going to solve this quadratic equation by factorization method. Y squared minus 5y plus 6 is equal to 0. Now, by factorization method, we will look for two values such that when we multiply both of them, we will get a negative 5, and when we add both of them, we have a positive 6. Those values are simply minus 2 and minus 3, because minus 2 plus minus 3 will give me a negative 5, and minus 2 times minus 3 will give me a positive 6. So I'm going to write these guys in this format. So I have y squared minus 2y minus 3y plus 6 equal to 0. Yes, this minus 2 minus 3 equivalently to the minus 5, and the plus 6 is still here. So the next thing, I'm going to group the equation in twos. So I have y squared minus 2y, and I have negative 3y plus 6 equal to 0. So I factored the common term here. What is common in this factor is y. So I bring out y, and I have, if y divides y squared, I have y. If y divides minus 2y, I have minus 2. As if to say y times y squared, y times minus 2, minus 2y. So whatever I have in this whatever factor I have here, I'm going to replace it here automatically. Then I have my equal to 0. Of course, there should be a value here. The value here will be the value such that when I multiply it with y, I have negative 3y, and that value is simply negative 3. Because negative 3 times y will give me a negative 3y, and negative 3 times minus 2 will give me a positive 6. You can see that these two factors are the same, and they must be the same. So we'll convert them to the one factor. So I have y minus 2 as this factor, and these ones outside, as if to call them the coefficients outside, will be the next factor, which is y and minus 3, then equal to 0. Then the next natural thing to do is to equate each of these factors to 0. So I have y minus 2 is equal to 0, and I have y minus 3 is equal to 0. If I solve this equation, of course, I cannot minus 2 from y. I have to connect like terms. I have to take negative 2 to the other side of the equation. So I have y is equal to 2. Or I have y is equal to 3. Now, these are the values of y from the quadratic equation. We have just obtained the values of y from the quadratic equation. Now, the next thing we want to do with these values of y is we input the values of y into our equation 3 to get the values of x. In other words, we input the value of y to get the corresponding value of x. So from equation 3, I'm going to put the values of y into equation 3. So equation 3 is simply x is equal to 5 minus y. Okay, so if I call this y1 and I call this y subscript 2, in other words, if I put y1, I'll have x is equal to 5 minus my y1 is 2, so I have 5 minus 2. So I have a corresponding x1. In other words, if I'm plugging in y1 into equation 3, I'll have a corresponding x1. So my y1 is 2, so I have 5 minus 2, which is equal to 3. So it means that when x1 is equal to 3, y1 is equal to 2. That's what this equation is telling us. So we do the same for y2. For y2, we have x is equal to 5 minus y. We put y2 into the equation. We have y2 to be 3 from our solution. So if I plug in y2 to be 3 into this equation, I'll have a corresponding x2, which will be 5 minus 3. So I have x2 is equal to 2. So what it means that if x2 is equal to 2, y2 also is equal to 3. So these are the values of x and y. These are the values of x and y such that the equation can be consistent. Let us verify these values of x and y from the given question. The question we are given is x plus y is equal to 5 and xy is equal to 6. We are done. We want to verify the solution. So if x is from this one, if x is 3 and y is 2, we have 3 plus 2, which is 5. And if x is 3 and y is 2, we have 3 times 2, which is 6. So it's consistent or is defined. The same thing when you try this other one. you'll get the same solution. So we have actually obtained the solution to the given simultaneous equation. Thank you very much for watching. I hope this helps. God bless.